Pre-statistics. Function notation, part 3. Lesson objective. Use function notation with models. Let's review input and output of a function. You're going to graph p equals f of r. What variable goes on the horizontal axis? Our input is r and our output is f of r, or p. Think about this as an order pair. It would be rp, where r is the independent variable, the input. Horizontal axis is the input axis. The variable r is the answer to this question. Number 2, you are given that h of a is equal to 1/2 times a. What is the independent variable? The independent variable would be variable a. Number 3, if 10 equals f of -4, give the coordinates of a point on the graph of f. Well, here we have an input -4 and the output is equal to 10, so that point would be on the graph. Number 4, if 9 is a solution of the equation g of w equals -1, give a point on the graph of the function g. So we know if 9 is a solution to this equation, that tells us 9 is the input, and the output we know is -1, so this point would be on the graph of g. If you recall, we've seen this example in a previous video involving functions. Write the notation where f is a function of r. So in function notation, r would be our input. That's what goes in the parentheses. That is the input. You put it in parentheses. And then t would be the output. And this is a function. Write the notation where r is a function of t. So now t is the input, and then r of t would be the output. Is this a function? Well, if you recall, we have a value of t that produces 2 outputs. So this is not a function. Lesson objective. Function notation with models. In this case, y is our dependent variable. Our independent is what goes inside the parentheses. That is going to be our independent variable. That's what goes inside, and we can think of that as our input. This is the function name. Our output is y. Our input is x. So in order pair, it could be written like this, or it could be written like this. These are equivalent. But what's nice about function notation is we automatically know what is the input variable, whatever is inside the parentheses. Function notation. Definition. The dependent variable of a function f can be represented by the expression formed by writing the independent variable name within the parentheses of f. Dependent variable equals f parentheses independent variable. So whatever goes inside the parentheses, that is going to be your independent variable or your input. We call this expression function notation. Example 7. Consider the model p equals 1.5 t plus 18.5, where p is the percentage of workers who telecommute at least once a month at t years since 2006. Rewrite the equation p equals 1.5 t plus 18.5 with the function name f. So in this case, t is our independent variable. T will be the input. In this case, p is the output. But instead of putting p, we're going to use the function name f. So this would be f of t. So the equation would become f of t equals 1.5t plus 18.5. Example 8. Let f of t be the model for the number of years, measured in millions, who own cell phones t years after 1990. Explain the meaning of the following statements. So we're given f of t, so we know t, since it's inside the parentheses, is the input. And that's the number of years after 1990. And then f of t is the number of people who own cell phones. And this is measured in millions. For A, f of 15 equals 120. So what that means, as an ordered pair, when t is 15, f of t is 120. So what does that mean? That means 15 years after 1990, there's 120 million people who own cell phones. Another way we could say that is in the year 2005, there is 120 million people who own cell phones. B, when the input is A, the output is 20.5. So this means A years after 1990, there is 20.5 million people who own cell phones. And C, when the input is 30, the output is B. So what this means is in the year 2020, there will be B million people who own cell phones. Example 9. 10 inches of snow is equivalent to about 1 inch of rain. Let R be equal to the amount of rain and S equal to the amount of snow. Write an equation for the amount of precipitation measured in inches of rain as a function f for the number of inches of snow. So we want to write rain as a function of snow. Snow is going to be our input, and then the output is going to be rain. So function notation using an f, we would say f of s would be equal to r. So the function notation would be f of s. The equation, since we know 10 inches of snow is equal to 1 inch of rain, that is equal to s divided by 10. So when s is 10, r is 1. So 10 divided by 10 is 1. So this is our equation. Number 2, evaluate and interpret f of 5. So when the amount of snow is 5 inches, we want to know how much rain is there. To evaluate this, we use our function s divided by 10. So in this case, if we find f of 5, that is going to be 5 divided by 10, and of course we know that is 1/2 or 0.5. So interpret this, we would say when there is 5 inches of snow, when s is equal to 5, the amount of rain, or r, is equal to 0.5. Number 3, find s such that f of s is equal to 5 and interpret your result. So this time we are given an output and we want to find an input s. So if we use our function, f of s equals s divided by 10, substitute what we know that f of s is 5, so we put a 5 here. So 5 is equal to s divided by 10. S is our variable, so we need to get rid of the 10, and since it is dividing the s, we do the opposite, multiply. So these will cancel. S will be by itself, but if we multiply the right hand side by 10, we have to multiply the left hand side by 10. So s is equal to 50. So what does this mean in the terms of this linear model? When there is 5 inches of rain, that is equivalent to 50 inches of snow. Thanks for watching.